Hello. In this ICP, we are going to discuss about the sentimental analysis by using one of the Skytech Learn classifier. So here will be going through the sequence of steps that are involved in the sentimental analysis. So the first step is to import the required library. So here basically we are importing the pandas as well as the NLTK, and from NLTK we are importing the sentence tokenize and the word tokenize. These two, sentence tokenize will split the list into the sentences, and the word tokenize will split the list into the words. And then we are downloading from NLTK, we are downloading the popular collection. So once we run this one, we see that the popular collection has been downloaded. After that, we will be reading the CSV data. So here the data can be anything, but here we are using a file, data that is a CSV. It has been imported from the GitHub, where one of the user has already used this data for the sentiment analysis. So we are using the same, just here we are giving the link of the particular path, and we are reading the data using the function read underscore CSV. This will convert here read underscore CSV will convert the data into the list, and by using the pandas, whatever we have imported in the previous step, and we are displaying the data. So once we run this function, run this step, we can see that the data has been converted. And here we see that there are 4 columns. First one, it's just a serial number. Next one is a ID. Next one is a label, and next one is a tweet. So this is the data that we got. Now what we are doing, we are trying to sort out the tweet text into the 1000 lines. So for that, we are basically using the whatever the CSV data we have obtained. We are keeping the head count as 1000, so that we will get the output for only the 1000 lines. So here, by using the panda that we got, we are filling the text into the variable tweet underscore text. So we are finding the length of that tweet text and the type of which it is. So here this is a string, and we'll get it the output as a string. So once I run this one, we can see that it is printing the what kind of variable it is, and its length, and the text here. So here we got 1000 lines of tweets. Next step is the tokenizing of all the text into the sentences. So here, as we know that, I mean, here tokenizer is nothing but the splitting. So here, here we are splitting it, all the text that we have obtained in the tweet text into the sentences. So for this, we have imported already a library from the NLTK. So we are using that function, and we are just displaying the data, and we are printing the length as well. So once I run this, there is a 328 lines, and this is the data. Next is next we are tokenizing all the text into the words, and then displaying the text as well as the length. It's the same step. So the library that we have imported from the NLTK, here we are using that, and we are displaying the length of that. So here the whatever the 1000 lines of tweets we have taken, we are splitting them into the words. So once I run this function, we can see that it is split into words. There are 11,942 words that are split. So after that, here we are importing the libraries for the frequency distribution and finding the most common words. For this, first thing is that from the NLTK.probability, we are importing the frequency distribution, and from that, whatever the words we have splitted, we are using the most common words. So here, most underscore common is the function that is used to find the most common words that have been used. So if we go to the top, if I execute this, and if we go to the top, we can see that how many times the word has been used. Here for this, hash has been used for the 979 times. Dot and dot has been used for 895. So here we can change the length. Here we have given it will show up to 11,975. Whatever the length of the word split, we have used that. So next comes the plotting of the graph for the frequency distribution of the 30 words. So here we have used the most used 30 words, and we have plotted the graph with the count on the x-axis and with the words on the y-axis. These are the 30 words and these are the plot. So for this we have imported the mat plot library.pyplot, and we have displayed it as a plotted it as a graph. So once I run this is how. So here we can see that ash is around somewhere around 900 times it has been used. So it's a graphical representation. Next step is removing all the punctuations from the splitted words. So here we know that, I mean, the data that we got from the splitting in the words, we have the symbol like at the rate ash, or we have many characters numeric. So in order to remove that, we are basically running a loop, and then we are using a function is of alpha, so that this function will only pass the alphabets, not the numerics, neither the characters or numeric. Then we are converting them into the lowercase using the function lower, and we are appending the data into the no underscore punc, which is the list that we have used to store all the data with no punctuations on the characters or numerics. So then we are displaying the list. Then next step is to finding the stop words in the English language. So here we know that, I mean, stop words are some kind of words that are used more frequently, which might have the same meaning. So here for that we are directly importing the nltk.corpus. From that we are importing the stop words, and here specifically we are only finding out for the English language. So here if you see, we have imported it, and when we run this, these are all the stop words that we have in the English language. So next step is cleaning the words. So cleaning here is in case is that whatever the words that we have opted after removing the punctuations, and now we need to eliminate the words with the stop words. So here the same, we are running a for loop with the list that we have obtained with no punctuations, and then checking it with the whether if it's there or not in the stop words, and then appending the values, and then we are passing it to the clean words. And the clean words is the list that is that consists of no stop words, no punctuations. So this is the clean words. Next we are using the frequency distribution to find how many times there was most common of the whatever the clean words that we have obtained, how many times they have been used. So here, for example, user has been used for the 379 times. So this is a frequency distribution. Next one is plotting the same most common 30 words on graph. So first time we have plotted it for the all the words. Now we are only plotting for the clean words. So here we can see user, which is around 379 of times. So now coming to the performing the word cloud. So here basically we are trying to use the most common words, or the whatever the words by using a list, and we are trying to capture it in a image format. So for this, first we are importing libraries such as word cloud, request, numpy.pil. From there, from the word cloud, we are importing word cloud and the image color generator, and then we are importing the request, and after that we are importing the matplot library.py plot as plt. Then we are masking it up. So for here basically we are trying to get an image online. So this is a file path where we have this image. So this is basically a Facebook image, and we are trying to add the words that we have used into this image. So here we are masking up the data. Then here, and then we are using the image color generator to mask up this image. So now for the workflow, what we are using is that we are using the background color as white. We have used the height as 4000 and the width as 6000, and we are masking it up. And the words that we are used was a tweet text. All the words with all the tweet text words. We have not used this as a clean words. We can either use the clean words as well to figure it out. And here we have given the plot size as 15, 15 figuring size. So this is the output that we get. Now next step is to stemming of all the clean words. Here stemming, we know that, I mean, if you stemming is of two types, potter stemming and the snowball stemmer. So stemming basically removes cuts the words without giving any proper meaning. It might sometimes give a proper meaning, but sometimes it might not give. So here we are for the stemming, we are importing the nltk.stem from the library nltk.stem as a potter stemmer. So then we are cleaning up the for the clean words, we are running a for loop and we are doing the potter stemmer. So here some might be a meaningful, but some cannot be a meaningful. For example, here familiar was the word, but here we are getting when it is stemmed as a famili ar was called. So this kind of issues might be happening. And next step is the snowball trimmer stemmer. And so here it is the same. We are importing from the nltk.stem library. We are importing the snowball stemmer, and with the English language, we are doing this, performing the stem for the clean words, and we are displaying the outputs along with the language. If we run this, we get the words as well as the language where it is the word that is used. Next one is the lemmatization of the clean words. Lemmatization is nothing but the cutting the word into its base form. So lemmatization or the stemming major difference is as lemmatization of words will give a proper meaning, but whereas stemming may not give the proper meaning. So here the advantage is that we'll get a proper meaning for so here we can see that everything has a proper meaning. Next one is parts of speech tagging of the clean words. Here basically we are using the NLTK library, and then we are tagging the parts of speech for the each word that we have opted in the clean words. So for example, success is a noun. So in that case, in that way, we are just tagging the parts of speech for each and every clean word. Next one is the parsing of the tag word. So here basically we are using the two operators, optional characters, or star is nothing but the how many zero or more repetitions. So here we are plotting. Here first we are importing the matplot library.pyplot, and then we are parsing the text. So here we can see that we have used the parser variable, then we are using the rg expression parser grammar, then we are displaying the output. So here we can see that how the each word is parsed. So here we can see. Next step is the named entity recognition. So here we are doing the named entity recognition for the each clean word for the tag word, sorry, and we are printing the output. So if we run this, we can see that each word has been named and it's recognized. Next one is a wordnet. Basically, wordnet is nothing but it's kind of a dictionary where we can find the meaning of each word. So here, for every word, there is a meaning. So here, basically, in this step, we will get to know the meanings along with the whatever its name, its definition, and the examples. So here we can see we are printing them. So since we have many words, it will take some time. Yeah, for example, here the word is attend. So here basically attend is nothing but the meaning of that is take charge or deal or off or deal with. So here uh, we have the example as well. Could you see about lunch? I must attend to this matter. So this is the examples for this. Then comes the finding synonyms and anonyms. We know that synonyms are nothing but having the same meanings, and anonyms are nothing but the opposite meaning. So here basically first we have initialized the two variables, synonyms underscore words and the antonym underscore words. We have, as a list we have just initialized. Then we are writing a for loop to find for loop for the clean words, and then here we are finding the synonyms as well as the antonyms for the clean words, and we are showing the output. So basically here we are writing three loops. First one is for the clean words, next one is for the from getting the synth sets from the wordnet. Then we are doing the lemmatization. Then we are getting the antonyms. So here it will display the synonym words as well as a antonym. Antonym words are both are appended, and we will be showing it in an output. Next comes the bag of words. So here nothing. Here we are using the Skytech learn classifier. So from here we are using the skylearn dot feature extraction dot text library, and we are importing the count vectorization. So here basically we are displaying it in a vector form so that the system understands it in a better way. So first thing is that we are creating an object CV. Then we are generating the output for the bag of words. So here by using the fit transform function, we are converting it into the bag of words. Here we are using the sentence split, and we are converting it to the array. Then we are displaying the output. So here it will assign the values for this words. So for user, it has assigned the value in 334. Basically, this is a these values are assigned in the alphabetical. In the order, and it is displayed as a vector form. In the matrix form. The next step is for doing the TF-IDF. So here basically it's the same. We are using the Skytech learn classifier, and from skylearn.feature extraction.now we are importing the TF-ID vectorization, and here we are creating the object. Then by using the fit transform function, we are displaying the splitting the sentence split into the array and displaying the output. Next, what we have done is that by using the Skylearn feature extraction document, we have imported the TF-ID transformer, and we are displaying the text. So this is the final output.